A-level physics, dielectrics. So in this video, we're going to go over what a dielectric is, right? What are they actually doing in capacitors? So there's a sequence of videos right now, just going over key topics to refresh your mind for that paper 2. So dielectrics, we use them in capacitors. So again, imagine we've got my capacitor plates. And what we do with our capacitor plates is, let's say we've got our switch and we're going to charge it up using our cell. The shorter side is my negative, the longer side is my positive. And what happens is these negative electrons go on to this side of the capacitor plate. And then the negative electrons on this side of the capacitor plate, they move off around the circuit to go on to this positive, or attracted towards this positive terminal of a cell. So if they lose electrons, it becomes positive, okay? So what we can see now is we've got a potential difference between these two plates. And we know the capacitance of a capacitor is equal to the charge divided by its potential difference. Now, let's say the potential difference of our cell is 8 volts. We know the capacitor gets fully charged when we close the switch, when the potential difference across it is always equal, to 8 volts. Okay, so the potential difference, that's set by whatever cell we're using. So we can see if you want a higher capacitance, that's when we can store more charge on the plates. Okay, so we're thinking, how can we get more charges on these plates? So what we do is we use these dielectrics. So dielectrics is a material that goes between the capacitor plates. And there's an equation in your formula sheet says the capacitance is equal to the cross-sectional area of our plates times the relative permittivity of free space, it's a constant in your formula sheet, times the relative permittivity of the capacitor, divided by the distance between the plates. So you can see that if we use a dielectric, we're increasing the capacitance. So if we increase the capacitance, we can store more charge on the plates. So how does that work? So a dielectric material is something like a polar molecule. So for example, water is H2O, right? So what that means is we've got one oxygen joined to 2 hydrogens. And what happens is, if you remember way back to your chemistry classes, there's these 2 free pairs of electrons there. So because there's more electrons here, that's going to be slightly negative, and down where the hydrogens are, it's going to become slightly positive. So that's why it's called a polar molecule, right? So you don't need to know how to describe what a polar molecule is. You just need to know a polar molecule is slightly positive one side and slightly negative in the other. So these polar molecules, again, I'm just going to write that down, a polar molecule, we put between the capacitor plates. And you can see what they're going to do is they're going to align with a field. So if this side is negative, what's going to happen is the positive side of the polar molecule is going to align with it. So now we've got all these polar molecules in here. So what you can see is, overall, if you look here, this was really negative before, but now you've got some positives canceling out the negatives. So it's less negative overall, right? So there'll be less of a difference between the two plates. Okay, so let's say the potential difference was 8 volts, right? Because maybe, I don't know, maybe this one was at negative 4 volts and this one was at positive 4 volts. But when we put the polar molecule between it, because this side got less negative, maybe it's now like negative 2 volts, and this negatives and these positive make this side less positive, so maybe it's like positive 2 volts. You can see the potential difference between them is less. So what happens is, again, we know it can charge up to 8. So what we can do is we can put more of these charges onto the capacitor plate until we can get back to that potential difference of 8 volts. So it allows us to store more charges on the capacitor plates.